Hello, hello, hello. Again, a little bit late. It's okay. Not even more than 15 seconds. There we go. Ooh, some other ASCII diagram. It's a square. Goes in the square hole, I would bet. Already got Quokka spun up. Data. Go ahead and put that on that line, that on that line. Great, we have data. What are you supposed to do? 31. It's some kind of pathfinding tomfoolery. Okay, wait. Height map. Okay, so it's a water thing. Start and end. Here you start in top left, go to the middle. You can go down or right. Great, pathfinding. Dijkstra's algorithm. Here it comes. Eventually, you need to get to the E and the above, indicate path, blah, blah, blah. Yeah, we're going there, Madeline. Okay, cutting it close, but we are getting there. 31 steps, few as possible. Great, so it's Dijkstra's algorithm. Whoa, what a blobby mess was that? But yeah, thanks for coming on by. Try not to make late a habit, but life is being busy. So what is up with this elevation? A, B, C, 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 down? D, E, F. Okay. Blah, blah, blah. A is lowest, B is next, all the way up to Z. Also included current, start, and end. Got it. Save energy. Okay, so this is Dijkstra's, but in a way like this. Okay, I think I... Oh, didn't have some things ready. I think I understand this. So I guess it's just JS Dijkstra's algorithm, and then for every position, it has a weight of its node converted to this. Okay, so first I'll convert this to const matrix equals data dot split new line. Then for every line dot split, correct. But then every line map car. Then it's gonna be car dot car code at code at 0. And then let's look at matrix. We want to reduce this to zeros for easy reading. Great. Then what is that? Minus 97? It would have numlock on. Great. 0, negative 14. Great, because they're all lower cases. So if any are negative, then they are start and end. Const x y equals 0, 0, but we don't use a const, of course. Let's start equals null for let. There you go. Thank you. If that is that, except that's not correct, I'll put the matrix. Yeah, start is negative 14. Great, so if also 97's a little much, 96. We want ones. So our start is negative 13. Great, we found start. Let end equals null. Figure it out. Great, manually writing it. Not negative 5, though it might be negative 5. We will find out. It is negative 27. I wonder what pattern it chose for 5, but that ain't it. So we have our start and we have our end. Now we need to Dijkstra's algorithm. At least cost path. There we go. Visited cost parents. Hopefully, these are all the parts I want. There we go. Men. I don't know about this. Just in your Copilot. Correct. Okay, we're not using a priority queue, which is why this is a little different. All of our neighbors, good. You're gonna pick one. You're gonna find the least one or least costly one and update the cost in the cost thing as so. Thank you. Update new cost. Well, hold on. Don't change the cost if it's less than. New cost is cost. I don't know about that. Oh, there it is. New cost less than old cost. Okay, I was about to be like, GPT, Copilot. Okay, current and hold on. Well, that's actually it. So what we want to do now, object null is not iterable. Great. Did we not make it to the end? Min key is null. Key value of q. Is that how you do that? We're gonna find out. Key is null. Value is null. So what is q again? Q is a null to 0. Well, that's not right. Start never got updated. Ain't that sad? It's not -31, it's -13. Whoops. Look at Q again. Well, this is the part where you look at the Q. Don't do this to me, Quokka. And if I'm using a Q, I'm using these as keys. Okay, guys, about to be like, how dare you use a new array as a key? That's never gonna work. You're not constructing this? Okay, do all by reference. So what I imagine is we hit an infinite loop at any point somewhere in here. Oh, you're constructing neighbors, are you? Ain't that nice? It's wrong. Wrong. Join. Oh, how dare you. There we go. It's starting to make progress. So every time you touch any one of these terrifying maps, gotta make sure min key correct. Neighbor of neighbors. Neighbor, don't touch that. Don't touch the min key, that's a string. Neighbor, you don't do that. Yep, your strings, everyone join the string club. There we go. Undefined length. I guess you're accessing if I is less than 0 or I is greater than or less than matrix I length. Okay, I can see the issue. Don't know why it's an issue. Hello, neighbor. You are. Oh, that is just terrifying. Ooh, that's right. Number math. I and J should be numbers. Hold up. Wait a minute. Nope, you just constructed this. Min key. There you go, you're a lovely string. We love you. We don't want you like that. Do this, map number. Drop those two. Good neighbor, good matrix. Great, now we need to actually return our path. Did we check our path? We have to track parents back, don't we? That's where we do current equals end, and we track our parents back. See, Copilot is good for this repetitive stuff. Now, why did it break? Hit an infinite loop again? Or what's up? What is up? Come on. This is the part where you don't... I love you, clock. I will pay you when I have money to. Solve, please. Solve, please. Please solve. Infinite loop. Well, current's not equal to start. There's your problem. I guess we never made it back to start. So paths, push current, parents, get current. Oh, end. You're not a thing, aren't you? Current dot join. Congratulations, you're a string. Current is not equal to start dot join. Congratulations, you're a string. There we go. Wow, that's impressive. I segfaulted JavaScript. That's old code. Don't know why that's in there. Choose not 31. So I want path. Watch my mouse not get there. Dot length. Not length. 1131. Well, that's not what I wanted. I wanted the least painful path. 25. Well, hold on. That's the end, isn't it? Get a console log on there. Again, another thing where visualization is just begging to happen. Though I'm not going to be getting any of this done. 10, 20, 30. Okay, great. So, for cost, key value, no, for change each chord and path and matrix to a dot. There you go. For chord, split thing, change it to... Okay, we'll change it to 0. And for log matrix, because we need a visualization. Okay, great. We're turning it all back to those. That's not exactly what I wanted. That's okay. To dot, I guess it's -2. Look at that. Okay, so we took this path. What is the actual path, though? Symbols indicate whether the path exits each square moving up, down, left, or right. Oh, no. I didn't understand this. Marks your current position. Few steps as possible. You can move one square. Can be at most one higher than the current is. Means the elevation of destination can be much lower than the elevation of current. Which is A and B. B is lowest. Okay. Destination can be at most one higher. Okay, so through my destinations cost, if old cost, basically for every destination, if this good, if visited good, if diff in height is more than 1, skip. Thank you. Oh, that's a terrifying if, but I'm gonna hope it works. At most one higher. At most, which means it can be one higher. Elevation destination can be much lower. If I hope I don't want that. If height is more than 1 higher, skip. I don't want an abs. Why are you absing me? The elevation can be at most 1 higher. Greater than 1 higher. Okay, I'll just do this manually, I guess. So this versus our current position, min key, I suppose, right? Yeah, min key 0, min key 1, although that is not 0 and 1, it is I and J. Or I have I and J. I need to use neighbor, which is also I and J. Goodness, that's not confusing. Convert all these I's to X's, I think. There we go. All these to Y's. I wonder if Copilot's confused. It's like, I can't do this. Okay, so if the difference between them is greater than 1, drop the abs. It's not being ran once. Well, that's not what I wanted to hear. Chord is possibly undefined. It's not. Oop, infinite loop. Gotta love it. Interesting. Do. I went straight for Dijkstra's. I assumed that would be accurate. I mean, it's got me a path, but not a good one. Based on the weird logic that I can't figure out. Okay, what if because I just need to invalidate them, right? I just thought that's what that was doing. Debug time. It's time to debug. There we go, we made it. Output the one. Output the other one. Yeah, 22 to negative 20. We can never leave home, can we? Dagnabbit. Because matrix is the 27 or whatever. Come on, turn off that. Go on, show matrix. 13. Yeah, we can never make it to any of these because their quote elevation is way too different. But what is the elevation of start and end? Current position has elevation A, and E has elevation C. Great, so we change it to those accordingly. So matrix start. If that is, they're not null. Go with it. TypeScript So we need to set it to the elevation of A, which is 1. Well, this would break my algo for sure. And it needs to be set to the elevation of Z. Do I have any Z's in the example? 1 to the left of E. So it is 26. There we go. That should make it happy, which means I bring these 3 back. Oh, it's not on fire. 11's not equal to 31. Why? So we go straight down. We don't go to the B's for whatever reason. You can move 1 square to avoid. You can be at most 1 higher. Also means elevation of destination can be much lower. Here you could start in top left with A. You could start by moving down or right. Eventually you'll need to head toward the E, spiral around to the goal. Whether the past exits move. Wait a minute. That's not true, because all I get is an elevation map. I don't get any exits. The symbols indicate whether the path exits each square moving... Oh, the pathing, I got it. Hey, there you go, pizza. I knew you would. I mean, you're already so far on it. But yeah, there you go. Progress is progress. Congratulations. Now, try doing it without regex. Or just take a break and come back later. A, B. Oh, the cost goes down as I go to lower elevations. B. Yeah, okay. It's all good. I mean, hey, regex is perfectly valid, but it can, much like not calling dot reverse, you can learn a little more if you don't use regex. So, cost of an equivalent thing is painful. Cost plus matrix ij plus 1. There's always an implicit 1 cost. 7. How dare you? Absolute dare you. Of course. I appreciate that. Yeah, some freaking Dijkstra's algorithm came out to get us. They're not going the right way. I want to go down. Technically, I want to go increase cost. New cost greater than old cost. That's the most expansive route. That's my algorithm. It is bad. Bad to the bone. Man, I know it's some kind of thing. Maybe Dijkstra is too dumb. The D in Dijkstra is for dumb. A star. I'm trying to think. Now, which path am I supposed to actually take? Path reaches the goal in 31, the fewest possible. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is literally 15. How am I bad at math counting this? Hey, Ryan, I appreciate it. Yeah, good evening. This also means elevation. Here you start top left, 31 steps. Who said 31? Is it the sum of all my... I think, does every elevation cost 1 to traverse? To avoid. if your current is M, you could step to N, but not to O. Huh. Huh, huh, huh. Hmm. So I can go up but down. Hey, I appreciate that, Ryan. Yeah, I gotta gotta try to get some sleep too. But yeah, I'll figure that out. Get that later, right? But yeah, I am doing well. Obviously, been busy, but it is how December rolls. So there's some logic behind wanting to go these directions instead. So we don't go to the right for whatever freaking reason. We go down. We go to A, and we go to B, and we go down instead of to the right. I don't see why we wouldn't want to go there. Unvisited squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Are we counting visited squares? That don't make sense. Hmm. Maybe we need to drop off to breadth first. I mean, technically, Dijkstra's, it is supposed to be depth first, but it does get to all of them, but not enough apparently, so mend E never equals key. That's fine. Oh, it does get executed a few times. 11 still 31. We love that. Path is still wrong. Okay, we love that. I didn't do what I wanted. Try it again. So first we need to keep track. So I think we've already done this properly. Like the matrix, I like my matrix. It is, well, I like the matrix down here. I have my front current, I have my end, and I have all of the weights of the thing. And I want to choose the one with the least weight. So 1, 2, 3, 4, 5, 7, 8, 9, all the way to the right. Then you gotta pick one to go up. 17, 18, 19, 20. TUVW. Yeah, that's correct. Oh, I see the spiral. Man, that is awfully confusing. My brain finally got it. 9, 10, 11, 12, 13. Because you literally can't jump these edges. But in my path, I was jumping the edges. That's the problem. Yeah, look at my path. I jumped the edges. This logic is not doing it. If neighbor height is greater than... Okay, I kept auto-completing Copilot, but maybe Copilot knows what's up. Nope, that's infinite loop territory. Here's the thing, I don't want to be able to go to any position that is like this. So I need to concentrate my neighbors, filter my neighbors. Right here, Q visited, Q delete. Yeah, pull out the smallest one, visited, and calculate that. Ah, of course, yeah. Nah, it's good, it's good. Hey, it's fine, yeah. I've been escaped two of time. I'm sure we'll catch each other again for sure. And put the number the other way. The other way. I need a graph. No, I need to limit what neighbors I have. What cost do I have? I have no cost. And then what cost do I have here? Yeah, everyone has a cost. This isn't... I need to not go directions if I can't go there. Physically cannot. Got filter. ij, I less than 0. That's true. Okay, this is literally you're in the thing. We don't care about that. Get rid of symbols. If if weight is 1 or it is greater than 1 higher than current, then it is not a neighbor. Return false, return true. Let's see if that works. Ix, J, Y, can't. X, Y, yeah. Oh, optional way. There we go, and yeah, that should work there. Oh, for crying out loud, is this it? Yes. Oh, painful. This is gonna be real hurtful. Trail should start as low as possible. However, the trail should still be direct, taking the fewest steps, shortest from any square to at elevation A to the square marked at E. Oh, literally any of them. Okay. So loop, iterate through all. Oh, this is okay. I think I can do this one. Loop through all of A's and choose each one as a starting position. This one is 29, fewest steps. Aw, okay. I'm not really going to get any higher on this because it's literally part 1 all over again. But I knew there was something wrong with my logic there. Glad I figured it out. Why is this on fire? Oh, because this is on fire. Too many colors. Great, I put that inside there. So what I need to do here is create an array of starts. And now my input array is still the same. So yeah, have my initial start. We love that one. Starts equals start for, please loop. Thank you. If -2, that's not right, because we're looking for 1. Technically, we already have that one. So let's not initialize. And here we go. We have our end. We update that for const start of starts. And then let best equals infinity. Drag that all the way up there. Hopefully performance isn't too tragic, but we will find out. Turn best. If path length less than best equals path length, please auto format and find out the issue. 31 is not equal to 29. How dare you? My starts must not have gotten initialized, and solve2 is not getting called. There it is. 16 is not. Oh, crying out loud. Who are you starting from? 0, 0, 0, 1, 2, 3, 4. So any on the left. Literally any on the left. Well, there's also 1. Hold up. Matrix 1. Matrix, yeah, I want all the ones. So after I modify the matrix, it looks like this. Yeah, so you have 1, 2, 3, 4, 5, 6 lovely options. Pick one. Matrix ij equals 1. Zero, 0, 1, 0, 2, 0, 3, 0, 4, 0. How dare you? Log. Right, 1, 2, 3, 4, 5. Which 1, 2, 3, 4, 5, 6. There are 6 of them there. Why are you not? Oh, because you break. You stop on that. Yeah, don't do that. There we go. There they all are. We love that. If we work now. 16 not equal to 29. Great. What is your path? Oh, there are so many of them. Whoops, what are these doing in here? Oh, because I mutated, didn't I? Yeah, I mutated my matrix. Don't do that. Also, don't log it while you're here. 16 not equal 29. Oh, infinite loop, or very big input, because we actually succeeded. We'll find out. I give her the big run. How many A's are there? Oh, someone's console logging something. 490. Yeah, that part was there. Well, scroll that. It's not that many console logs. Log. I guess that's part one, thankfully. Okay, so I cleared that out. Hold up. Someone's... Oh, it was freaking terminal being all weird rendery. Part one. Okay, so that technically works. Huh. Again, I know there's gotta be a better solution. Which is what I guess I'm gonna have to rewrite as this thing runs forever. It eats my memory. Because the problem is there are too many A's, right? Yeah, there's way too many A's. Kind of need to pre-eliminate a lot of these in some way, but I also need to try all of them, or else I won't know. Well, that was a great thought. Interesting. Maybe I overcomplicated my pathfinding. I just need... So I already have seen. I definitely need that. Visited, right? And I have my visited, and I have my queue. Oh, what? Why'd you start moving? Oh yeah, because you're trying to do big one. Please stop. Big thanks. Yeah, again, I know this works, just not working enough. The fact that I'm doing all these joins and splits is definitely not helping. Is it problem though? Or is it the algorithm? So it's the same algorithm either way, just gotta make it better. Now let's drop some of these logs. Or quokkas. Right, okay, so we're going to try to simplify this. And again, we have our working here. So if we know, we know. We got a good test case there. So we're keeping track of all the starts. We have all that part. We have seen. And then we need to go through. So traverse through our queue. It's not really a good queue, but it's a queue. Thing is, this needs to be an actual, what is it? A deck, right? JS. If I was in Python, I could just import this, but I am not. I think this is what I need. I need the optimized one, the one with a priority heat, max heat, priority queue, right? JS. There we go. I think just give code. I need the Python version of this. You know, I know how to write the Python version of this. Just don't know how to freaking convert it like that. I mean, I have a template. Let's use the Python one. There we go. So this is all fine. Yep, great. All this is going. I haven't ran this in a while. 1, solve 2, test 2, bring in the code, bring in the code. Great, that works. Our expected value is 29. Turn numlock back on, how dare you. There we go. Wow, there's lots of things running, but let us reconstruct this. So first, I think my matrix, I can dematrixify it again. This is going to be basically one for the first top half. Again, I think this is going to be quicker than me finding a working priority queue in JavaScript. Although actually, I can probably tell it to do it like this. Excuse you. Control Shift A. Alright. Come on, you. Thank you. Okay, let's focus on this. Copilot seems to have it. For every row, for everything, find the start, set the start, create our new starts. Good. Don't do that. End to none. Find our end. Good. Then, oh, BFS. Let's think of that. There's the freaking deek. Now it's missing a bit of logic here, so let's not forget this. You know what? Come on, Copilot. Flex your muscles. Try it again. Best is infinity. There you go. For every start. Hope she's thinking a good thought. Oh boy, it's trying to do all of it, isn't it? Also, starts is not defined. Don't know why you didn't want to define those. Starts. Okay, it's this indentation being angry. Understandable. I can fix that. Indentation looks fine, actually. Oh, because I typed it there. Yeah, okay, that is going to be angry. Whoops. Fix that. Drop that. Drop that. Big sorry. Oh. There we go. Visited queue. Converted it to a string. Oh, because of my code was all strings. Well, great thing is you don't need to do that, but in theory, let's see if we can save that. Great, unindent all my lovely comments. Boop. Bada. Bada. This is the point where you would print. Oh, because I'm not running it yet. Test 2. Don't have my suite going on. Invalid int for base 10. Right. Split map int. There we go. So we stop our stringification. That should make life a lot easier. Min key is none. There we go. Just use min key like that. Stop doing the stringifications. Tuples do have identity. Stop. Oh, the stringification. My word. Okay, gotta do all these delays. Should be good. Unhashable list. Great. 69. If neighbor and visited. Neighbor is you're supposed to be a bunch of tuples. How dare you use inefficient data type? Assertion error. Great. So it did not do what I wanted. Print best. 7. Okay, my logic for the neighbors did not get implemented. Here it is. Yeah, it's literally they just did. Copilot was like, I don't know about that one. Okay, let's figure this out. Neighbor and visited. Continue. If weight is greater than 1 higher. Current. Thank you, Copilot. There we go. We good? We got no wolf. I can't tell. 23. What was I supposed to output? 29. So now we're undercut. This is part 2, right? Which means the algorithm did not get translated correctly. Set Q. Oh, this is great. Move, add, which means it wasn't JavaScript, it was me. This one's a stumper, folks. Okay, instead of copying it, should have just wrote it the right way. That was on me. So we have our starts. That's true. We don't actually need to use those. That is our initializer for the deck. D equals collections dot Q. Again, I know how to say this every time. And what we're gonna do is for starts, we're gonna keep track of the latest position of these. Do not. Oh, let's get rid of this comment. It's confused now. D dot, what is it? Append left? Append? I don't know, but it's we're appending a tuple containing the start and 0 as our priority for the queue. And then we start doing yeah, but we also want scene equals set Python way. Copilot will figure this out. Conceptually. Let's make sure this is this. If chord is just scene, good. Then add to scene this pop left. Hope that's right. If we got the exit and cost is best, good. Continue. Yeah, we'll do a continue. Then get all our neighbors. If that, good. We add to our neighbors. Oh, we add to our queue, that's right. Then we return best. Search an error prime. Why? This seems logical in my brain. 228. Holy no. Big no. Big no. Oh wait, I'm not supposed to be best is cost. Yeah, best is the cost we've got to so far, right? I'm supposed to take the cost plus 1, not plus elevation. 23. 29. Is it supposed to be 29? Is this consider the example above? 6 choices for starting, 5 marked A plus the S that counts as A. 29 steps, few as possible. You're going literally faster than you should be possible. Let's get rid of all this comment code. Come on. Start and starts, add them all to 0. Well, I could just do this, I think. I don't need to do that. Coordinate and our chaos, we pull that out. And we go in all the directions, all of our neighbors rather, right? We got our new, I guess we did that here. If we're outside, good. If new version, maybe this logic's wrong again. Neighbor, ooh. Okay, no, neighbor's fine. They're tuples. We love tuples. Maybe this one's wrong again. It seems to be going more than it should. Did this change? Any square to... No. Should still be direct. Did they change it? Drop this? Heck no. Okay, let's figure this math out again. Because the reason, for some reason, in here, this did not like. Yeah, there's a reason I had to do the filter out there. Yeah, so if I just do literally the same logic here, does this still work or does this explode? Okay, this does still work. Okay, so that didn't actually matter. If visited ij is greater than x plus 1. There's something wrong. Is that Wallaby I see? Yeah, you definitely see Wallaby. Well, you see Quokka, which is Wallaby's cousin. But yeah, they both do the same thing, just Wallaby's for test, Quokka is for normal files that you're not running tests on. But yeah, it's Quokka. Quokka Wallaby. Same company. 23. Yeah, it definitely helps a lot for that quick response. That's what we're all here for. Maybe it's, no wait, it's the first one, right? If best, yeah, all this logic, it should be literally the first one. Return cost. That's the whole point. Is that it will always be the best. Ever was. 23, how dare you? Huh. Or is at the end, then we're living life. I assume my matrix is correct. All my starts are correct, right? Let's check my starts. I first show that. There we go. 0, 0, 1, the one weird one, and the other normal ones. Yes, that is correct. Yeah, this is error lens. I'm also doing this in Python, which is I'm not really set up for, but that's why you see a lot of error. Yeah, error lens is the one that's doing this. Again, trying to point this out, my brain. I'm not seeing where it went wrong. Maybe we'll go back to the JavaScript one, because that one I actually got on the bad one. It's just on the good one. I mean, yeah, this is literally Dijkstra's. This is why it's easy but bad. Parents, cost. Yeah, I've embedded the cost into the result. So it's the cost. Oh, back to the Python. Nope. Control Shift T. Maybe I did that math wrong. Cost equals cost plus 1, right? So we take our cost and it's always the next cost. Yeah, which should basically count up how far it takes us to get there. And we literally can't go certain ways. Right. Let me print chord and cost. Where do we go? Yeah, you try your best and then you make it 2, 5. And where's my thing? 0, 1, 2. Oh no, it's up here. 0, 1, 2. 0, 1, 2, 3, 4, 5. So you make it to the end. But you make it there too quickly. You skip a step. Maybe I need to hard code some limits because the JavaScript one does work. So I just go really far. Right, I just brute force it. Hey, I appreciate that, pizza. This is a tough one. Definitely losing my edge on here. Do do do. Mm. I must have. Can't be that expensive to do all these. Convert coordinate. Okay, let's see. Function convert coordinate to single number based on matrix size. Thank you. Chord to num. Do math. Thanks, math. I love math. Maybe that's what we need to do. Now, do I actually need... I need X and Y to get around. Now, min key is from the queue. So whenever I put stuff in the queue, it's got to be correct. I also got to be able to destructure... I'll put it right the other function. Function convert single to a coordinate based on... There we go. So we just math our way. Oh, are you doing a floor? I hope that's right. Moment of truth. Okay, congratulations. No longer doing this. Boop. Oh, dagnabbit. All of this. Yeah, min key. Congratulations. All of these. Yeah, you're not... I mean, I guess you will be. When I split you in half. Num to chord. Min key. Congratulations. Equals end. Yep, I guess that parses. End equals... Oh, great. Gotta put all this up here. Chord to num. End. Same for start. So this will be a let start. Start equals chords to num start. Congratulations. Ignore it. Come on now. Thank you. Neighbors, X and Y. That worked. Cannot read undefined. Nan, how dare you? X and Y. X, Y. 0 and Nan. That's exactly what we want to see. Min key. That's a string. How'd you get in there? Oh, it's got in here, right here. Oh, there's another one up there. Num. Chord to num. Neighbor is not this. I mean, neighbors are coordinates, yes. Argument is numbers, not assignable to primitive type number. These are all things. Get over it. There we go. That makes them happy. Don't join that. Nope, come on. Current's not equal to start. Start is a thing. It never got updated. Equal to start. Come on, figure out the thing. Chord to number. Chord to num. It is. It is. Current's a number. This is start. It's not a number. Oh, this start isn't. Why do I have access to start here? Oh, this start is a number. Okay, you're fine. Be cool, Quokka. Be cool, I said. Alright, great. So... where's my terminal? Show output. Show output. Something else is caught up. Here's one. Oh, here's another one. Visited has here. Okay, we're running on that one. Please go fast. Okay, we'll send it on the real one. I got a console log lying around. Clear it, rerun it. I mean, that console log actually was kind of indicative of something. 1, 2, 3, 4, 5, 6, 7. How many A's do we got? Dang nabbit. Which one got too big? Hmm. I have to implement a limit. That's what's up. Max invalid size error. It's one of the sets, I bet. So if Q size, thing is, I'm going through all of them. Map set visited is probably the one. If visited size triple equals 1000000. If you're a million, give up. Just give up. And then this, hopefully this doesn't infinite, though it looks like it is. Getting the path length, so this is going to be for I0, caret size, and I less than a million, I plus plus. Keep on trying, you. Why? Why? Come on. Oh, it's because it's actually running now. Right. Hopefully that million should keep it from exploding. If you don't get there in a million, you have failed. Yeah, what's this number? That's bigger than a million. Come on. Hmm. Don't I need so? I need depth first. No, not the first to find it, but still running. Okay, this might not again be the option. Okay, let's break this out into its own little function then I suppose. Because this is breadth first search, which is working, but not enough. Why? Are you done? Nope, still running. I know this is technically Dijkstra's. Okay, so let's do BFS to find path from start to end. Maybe I messed it up. Come on, Copilot. This is where you can do stuff. Oh. To find shortest path from start to end. Oh, you abandon me now in my time of need. What the heck's that? Partial mode. Weird. Okay, write code implement. This is literally what I have already written. How dare you? Well, something just happened. Oh, something else. Nope. Okay, back to scratch with you. Again, we love you, but we do not love you. Okay, it's failing. Great, we love a good failure. Yeah, still gonna go for this one, because it sees my above code. That's painful. Great. Solve 2. That's why. I've biased it with my bad code. Probably will help if I spelled the word shortest correctly. Okay. See what part 2 comes up with. I'm not thinking of anything that I haven't already tried. Maybe it's not breadth first search. So it works, just not fast enough. Maybe I need to sort the A's by the closest A to it. That was my problem. Is this thing running? Still running. Then that might be good enough. Okay, yeah, you're not gonna run anywhere, and you're not gonna go anywhere. Okay, so for all our starts, let's try it. 3rd time's the rewrite charm. Let's look at starts. Come on, Quokka. Yep, these are all my starting positions. They are accurate. Matrix. It is accurate. Okay, seems right. So now we're going to convert to our start. We will make a queue. We gotta have a queue. Right, so that's going to be a queue is going to be our start positions, kind of like the Python one. Starts map. Each start coordinate becomes, I guess I'll make an object since I'm manually doing this. Chord start cost 0. There we go. That's our current cost. And while we're running, while queue, nope, we need to get the 0th of the queue isn't at the end. Manually doing my deck completed search. Dot chord not equal end. Of course, I'll need to chord to num. I assume this is a square. 173. Son of a. Great. Great. Chord. I don't think all those number functions even worked. Because that works on square logic as far as I'm aware. And then Q0 chord equals end. Don't worry. If end. Come on, code. Don't do that. Great, so while that's going, keep going, and chord and cost, we do want that. Close that off if cost greater than best. Yep, fail if you made party or too slow. Add the closing curly there. We want our neighbors. We also want our scene, so we do want a scene array. Cost scene equals lovely. We'll use an array because sets apparently are too freaking big. If it's already been seen, toodaloo. Don't do that. Stop doing that. Oh, we need to do something though. Scenes an object. If scene No. Chord, we'll break this out into X and Y. X, Y, question mark dot. Cost is greater, right? Chord does not exist. I'll just use, yes, it does. It does though. Because there's chord number or undefined. It's not undefined. There. The scene X has any. Right. Do that, I guess. Do something. Cannot be any. Blah 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 blah. Find your a record of string to the word true. Generic requires 2. Oh, great. Key is technically your keys are numbers. Congratulations. Your type safe. Number. Not what we're looking for. Number. There you go. Blah blah blah. Why is this never run? Why do you never run? While Q equals end is not equal to the end, darn ya. While you're not there. So it'll be or. They're failing. There we go. So we're gonna go through again all of our directions. Yeah, I guess we had to add it to scene first. At some point, yeah, okay, so scene equals, nope, come on, get back, get in there, do it. There you go, and then scene Y, congratulations, got the upgrade. There you go, all of our lovely neighbors, same ones again. Filter. There you go, don't want to look at you. I think that's the logic. And for every neighbor, this logic is similar. If you're outside, get out of here. Otherwise, push to the queue, the new position, and the cost. Uh-oh. I'm seeing this literally the same as my Python code, and the Python one obviously ain't working. Return best. Instead of returning best, return Q0 cost. Does this still happen? Up the queue. What's all this code doing here? 490, 480. What? My. So I did have it right in Python. I just haven't written it in so long. Well, hopefully at least top 5. But man, that was a tough one. Hey, still top 5. Phew. That was a toughie. Know your algorithms, folks. Basically what this one rattled down to. Do you know your algs? Oh, this is solved too. And I was wondering, like, what's this doing here? This is all old code. Oh, we got through it. Looking forward to that refactor. It's gonna be a big one for sure. Okay, let's drop all the quokkas. Make our commit and fix this thing up. Good enough. Be quiet. And almost got the Python solution of all things. Another one that will quite easily benefit itself to a visualization whenever I get that time back. Let's go ahead and start the first one, or part 2 actually, because that is basically, I think this is BFS. Math first search. I just couldn't implement it. So function BFS start number matrix. This is a array, so number array. You return a number. Congratulations. Oh, we also want an end, don't we? Yeah, I guess the matrix will go first then. Oops. Ba-da-ba-da-doo, da-da-doo-doo. Too many symbols. Fix that music. There we go. Okay, let's go copy this code. There we go. Well, I guess technically I could take multiple starts. Okay, yeah, we'll make it an arg param at the end, since it does seem to be performantly impactful. There we go. Starts. Congratulations, you made it. Are you angry? Q, yeah. Oh, that's not right. Start isn't a number. There we go. Fix that for you. Great. BFS. We love that. Now down here we can use return BFS with starts. Matrix end and starts, I suppose. Why you... Oh, end is dumb. There you go. Figure that out. Starts is also dumb. Congratulations. There you go. Still works. Next one here is going to be function parse elevations. Lovely. I think this one might be able to handle its own. Loving our matrix. Oh, there we go, yeah. Yeah, I don't think this is necessarily part of it, though we'll let Copilot have her fun. Lovely, but you're not just returning the matrix, you're returning a tuple of the matrix and the original start position. Nope, too many that way. Excuse you, don't worry, this is... Whoops. Daisy. Oh, I guess I can just... Alright, so it is like that, or null. But I can assert, we got you. Yep, that is good. Here we can say parse elevations, yours truly. Parse elevations, data, but we care about 0. There we go, and you collect your own starts. Apparently there was some end parsing. Whoops. Okay, I guess we would like to make an object out of you. Alright, let's bring that down on here. Yeah, so now you're returning an object. We'll let you infer. You can infer, you're cool. Matrix end. There you go, we can get rid of this one now. Lovely. And we can make some good assertions here. Because we're already making them here, and it would have exploded otherwise. So that makes that much at least easier. Let's make these same improvements to start 1. Or solve 1, rather. That's how words go. So we need start and end. So const matrix equals parse elevations, theta, start, end, and we do need that matrix. There we go. And now, instead of running this, we return BFS. BFS matrix end start. Good. Glad to see numbers still working. I guess solve 1's that simple. Now for end and start, we can simplify theirs to looking for both, actually. So if you find this one, you might as well be looking for that one. Then here we can say if end and start, break, if end and start, just being a little friendly. Yeah, that's good enough. We can make that nice and aligning. And just a little bit. Yeah, it looks good in my book. Okay, that's good for there. There it is with an auto format. Solve 1 hasn't changed. Solve 2. Yes, I think that's the best way to do it. Now, BFS. Time for your makeover. I guess we don't need best anymore. Cost, this is what we need. Scene X, Y. Gordon's neighbor. Terrifying filter. Drop this into a continue. Have a good day. Loving that. So this can be comboed into here. So if you're in the wrong spot or you're in the right spot, but you ain't got enough to go on, continue. This can be inlined. Well, not like that. Like that. This is keeping track of my scene using an object. Shouldn't be using one. I can use... Technically this works. Instead of this though, I can do a record of sets that are all of numbers. Has Y. There we go, a little performant. Equals new set. Congratulations. Dot add Y. Not read why you angry. Why you angry? There you go. Instead of using a record, of course, I can use a map. New map. Go ahead and type this up. No. There we go. Congratulations on your free upgrade. Yeah, so if, let's figure this out, if scene.get key has essentially the same logic. Scene.set x scene get that or that. So basically if not has, if not scene.has x scene.set x, congratulations, just got an upgrade. Then scene.get x, we know you're there, add y. There we go. Nice 2D matrix, essentially. Yeah, that all belongs right there. Drop that continue to one line. These are my neighbors. Still need to collect all of them. Only push the ones that are good. Don't need that check anymore. The IJ is already validated at left hand, although I can probably wash these checks into here. This will always be false. Never mind. Cannot read if undefined. Reading is 0. Thought that did that. Or 0. I mean, I know why it's throwing off. I thought you would save me. Maybe X and Y. Okay, that's fine. Do it the proper way. Be all posh and proper. Could swap this to an and, but you know what? Let's go ahead and swap this. Make it a positive assertion instead. There we go. And with that, it came back down to sub 100. I'd say we can... Where'd GitHub go? Wake up, GitHub. There we go. Phew. Let's go check out the good old Reddit. See what the actual good looking solutions were real quick. And then we'll find someone else to raid. Don't freak out, VS Code. VS Code be freaking out. Okay, let's look at the fancy ones. No code by hand? What kind of mad person? Wow. Absolute wow. Python 3, Network X. Ah. Go backwards to the destination. Let's check out the cool code. Graph library. Okay, everyone using a graph library, apparently. That's cool. Breath first search. Yep. From all SNA. Yeah, I thought I just... Okay. Yeah, this is what I try to do in Python. Oh, I even use the same structure. What did I do wrong? Show me the fellow JavaScripters. There's 3 of us. do. Oh, look, my million. Okay, that's less than a million. So maybe that's what was my problem. For every direction, if in range. Oh, that's a cool thing in Python. You can just be like, are you in this range? And it figures it out. There, new destination. It was just that off by 1 line about, huh? Oh, this is JavaScript? Oh, someone else also hard-coded at upper limit, it appears. Well, I do not understand. Okay, all 4 coordinate directions. That's what it is. Wow, 500 for both. Starting and ending. It's an easier way of doing it. Here's the queue. While queue and final. All directions. You don't have a scene. Oh, visited. There you go. Oh, they were able to use the string. Yeah, it was literally the algorithm, not the string doing it. For directions, make sure it's all good. Part 2 was just wrapping it in a loop, I guess. Final path. How do you calculate final path? Path concat. Oh, okay. So once you are at ending, path is the end. Interesting. Okay. I'm not gonna pretend to understand that. Hey, look, this is what I did about cost. Hey, okay. Oh, they use an array. That's easier. Yeah, that one. Definitely one of the rougher ones this year. But we eventually got through it. Appreciate y'all coming by. Let us find someone to raid. Again, any suggestions in the chat?
But yeah, not my best one, but we made it through. Oh, Adeline's off. Not fix that. Do. Yeah, Nick 1 data sign. Haven't been able to get to them just yet. Let's see if they're doing stuff. Hey, base. Come on, Firefox. Don't do me dirty like this. Hey, yeah, they're doing some Advent of Code. Oh, yeah, sounds cool. So, we're gonna make it over to Nick1 Data Sign. For those who don't know, friend of 100 devs. Leon's raided them a few times. The bot is offline. You can find it right there. I think that'll give you a link. There you go. That's a clickable link. But yeah, we're gonna go ahead and mess with them as they not necessarily do Advent of Code, or at least they are somewhat, but they're doing math stuff, so it's gonna be fun. Yeah, I will catch you, of course, tomorrow for Advent of Code Day 12. See ya.